All right, so let's be a little bit more formal about this. On page 4, what are the important ideas when it comes to decision making with significance tests? So we have to realize that errors are a real part of life. Can't avoid them, really. So kind of to summarize those possible errors, I'm going to make a two-way table, if you will. I'm going to look at the two things that we're comparing. So our decision from the test, do we reject the null? Do we fail to reject the null? Compared to the truth, is the null true or was the alternative true? We don't typically get to ever know this unless you had your entire population of whatever it was you were studying and you found the true average or true percent. Well, then you would know if the null was true or if it was the alternative. But since we don't get to know that, we're doing our best to conclude that we want to see what our outcomes tell us. What are the possible errors that could happen? So in the two-way table here, I've recorded assuming that the truth is that the null is true. So let's assume the null hypothesis was true, but our decision causes us to reject the null. Well, that's not what we would want to happen. That would fall into what we call a type 1 error was just made. The null was true, we chose to reject it, the statistics told us to reject it. That would be a wrong decision, and that's called a type 1 error. Now, if the null was true, and our conclusion was to fail to reject the null, we don't reject it, well, that's good. We made the right decision, so good job us. What if the alternative was true? If the alternative was true and we rejected the null, that means we found convincing evidence for the alternative. Beautiful, we made the right call. But what if the alternative was true and we did not reject the null? We did not find convincing evidence for the alternative. Oops, we made an error. That's called a type 2 error. So kind of a quick summary from this table would be a type 1 error is when you reject the null but the null was true. A type 2 error is when you fail to reject the null but the null was false. Okay, so let's look at an example with that. Are these potatoes keepers? Let me focus us in a little bit better here. We'll slide this up. A company that makes potato chips requires each shipment of potatoes to meet certain quality standards. If the company finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent back to the supplier to get another load of potatoes. Otherwise, the entire truckload will be used to make potato chips. The producer will perform a significance test using the following hypotheses. So first, assume the null true percent is actually 8%. They have a good shipment. As long as no more than 8% are blemished, they will accept that truckload and on to the chip factory they go. The alternative is that the true proportion or percent is greater than 8. More than 8% are actually blemished. If they conclude, if that is the case, well, that's a bad shipment. They're not going to use those potatoes. They'll send them back and ask for a new shipment. P represents the true proportion of potatoes with blemishes in a given truckload. So here's what's going to happen. A supervisor selects a random sample of 500 potatoes from the truck and finds that 52 of the potatoes, so 52 out of 500, results in a sample proportion of 0.104, so 10.4%, actually were blemished. The resulting p-value, again, we have not calculated that yet, we'll get there soon, but let's just say they've done that for us. They've calculated the p-value and they found that that is 0.0240. So again, if we're interpreting the p-value, we're looking at the probability of getting a sample of 500 potatoes to result in 10% or more being blemished. If the true shipment is only 8%, have blemishes, it's only going to happen about 2% of the time purely by chance. What conclusion would we make? At the 0.05, we call this our significance level. So because the p-value is 0.0240, which is less than alpha is our symbol that denotes our significance level, We reject the null. We have convincing evidence that more than 8% of the shipment of potatoes have blemishes. Reject the shipment, send it back, we want new potatoes. What are the possible errors? Now, we rejected the null hypothesis. So when we make our decision, there's only one potential error. In our case, we made the decision to reject the null. The error that's possible here would be a type 1 error. What if the null was true? What if that truck really did only have 8% or less blemished, and that sample of 500 resulting in 10% being blemished was just a fluke? Well, that's a bad decision then. We made a type 1 error. But I want just for the practice for us to describe what both errors actually would be in context, knowing that in our scenario, type 1 is really the only one that actually has a potential of occurring because we rejected the null. But in this context, a type 1 error would be described as finding convincing evidence that the shipment has more than 8% defective, but it really did not. The full truckload really did only have 8% or maybe less defects. That's the possible type 1 error. Type 2 error would be we did not find convincing evidence that the shipment is bad, so we keep it, but it really is bad. So we fail to reject the null hypothesis, but we really should have, because more than 8% actually are bad. Okay, maybe pause the video and think about that for a little bit. What are some consequences? Well, the consequence of a type 1 error, the supplier is upset with us because we tell them, send it back, this truckload is no good, but the potatoes were fine. In general, no more than 8% were defects. We sent the shipment back, potatoes were good, supplier is upset with us, maybe they don't want to do business with us again, I don't know, but we wasted a bunch of potatoes. Type 2 error, we don't send the shipment back, but we should have, means we're using some dud potatoes and our customers are now going to get more chips that have defects and blemishes and they don't like the taste of them or the looks of them, and now maybe our sales go down. Customers are now more upset with us. Ugh. Which error is more serious for the potato chip producer? So we're the producers. We have to think which one is worse. Well, from a business standpoint, if sales go down, money in our pocket goes down. Business starts to drop. Maybe I end up going out of business. Another company that makes potato chips kind of takes the lead. I don't know. I'm thinking that possibly type 2 error is worse for us. It's a little tougher to say here. Not quite as obvious as the water problem in the last, whether we should switch to bottled water or not. It wasn't a life or death situation. But I'm thinking maybe a type 2 error here because the chip producer would want happy customers, bottom line.